What we're going to talk about in this video is remapping. This is a fundamental technique for working in the node editor, as we will frequently need to remap values from one in and out point to another. First of all, there are many connection situations where you have to remap because of the connection type that you're trying to plug into and the kind of data that you're pulling from. The other great use for it, especially for those who are not so comfortable working in the node editor, and particularly not so comfortable with the whole number aspect of it, it gives you a tool that lets you simplify values coming from an output or network to make them more manageable further down the line in other networks or other parts of the same network. One of the most common tools that we use in remapping is of course the gradient, which takes an input value, in this case the x-coordinate of each point, polygon and so on the mesh, and translates that here into a colour value, as I have it black to white, which numerically is equivalent to 0 to 1. I've then got that driving the luminosity, and of course what we get is at x0 we get black, and at x1 we get 1. Obviously he's got some negative x coordinate here, so you can start going into the range there, which is of course the range of the input value. What you are essentially doing here, of course, is remapping one value, an x-coordinate, into another value, a luminosity. And simple as it is, in essence, that is all that any kind of remapping operation is. Taking one scale, in this case -4 to 1, or -3.7, or I should say, seeing as that's where my key is, and redrawing it with a new range of values, in this case 0 to 1. As I said, this can help you simplify numbers. So if we imagine that we had something we were trying to position at a given x-coordinate on our bunny here, but we didn't want this to be the origin, as in x0. We wanted x0 to be back here and x1 to be here. Then of course to match it up, since our 0 to 1 range wouldn't match with the actual 0 to 1 meter spacing either in our object space or world space, we'd have to start creating a multiplier and a subtraction to essentially shift where the x was going. But rather than do that, we can just remap it. So we've saved ourselves a bit of math and created a nice new simple pair of numbers that we can work with much more easily if we needed to go on and multiply, divide, whatever, this value further. And so of course, whilst we have the gradient and curve nodes, which let us perform remapping operations, there's also others like the dB and W remap node, which allows you to remap values in a number of ways. Can take either a vector, or of course colour, or a scalar. The in, max and min define the range of the remap. So the way I just had my gradient set before there, my input min key I had at -3.7 something, and the key 2 setting the maximum was 1, and my output min max was 0 and 1, black to white of course. So if I basically take the same value here, the x-coordinate from the object spot, and take that to the scalar input, then of course I get the same result as we had before, with an exception. You notice the bunny tail is getting brighter. If we look at his surface, we can see that he's grey, not white. That's why he didn't become bright white before. The remap node just keeps going off and off and off, mapping higher and higher with the same proportion. If I wanted it to behave like the gradient and clamp at either key value, then I would simply hit the clamp values. So as we can see, this basically does the same thing as the gradient nodes there. It's just more obvious the numerical aspect of it, even though we still have those same requester fields in the gradient. We also have the advantage, of course, that it takes a vector or colour, and it can also take a function. A function is another kind of remapping, and we see if I plug it in, we see that what it does is to further map these values here. Just to demonstrate quickly with this function, I'm going to leave it at 0, 1 and 0, 1. This is quite a big bunny, and this is the 0 to 1 meter range. By increasing the amp, we see more of a variation there, and we see what's happening is on this side, the y-axis of the graph represents the output value, the x-axis represents the input, of course going between 0 and 1 on either side there. So where it's coming up here, so a little over 0 on the input, which is the x-axis, we come up to near 1 on luminosity, and then as we come to near 1 on the x-axis, we start to dip down again towards 0 or black, before finally coming back up to a mid-grey there again. So like this, functions can also be seen as remapping tools. And the analogy with things like the curve gradient is pretty obvious. But functions are functions, including of course things like sine. It's not just a curve, it is an actual function that modifies a value, just as all the function nodes are. But what we start to see when we use it like this is that it can also just be seen as another way of remapping. And that goes, of course, not just for the function version, but for the math versions of the different trig functions as well. Sine and cosine take angular values and convert them into 0 to 1 range, or negative 1 to 1 range rather. They just remap. The same with the inverse functions, arc cos, arc sin. They take a scalar value and convert it back into an angle. In both cases, of course, 0 to 1 or 0 to negative 1 representing a range of 90 degrees. And then, of course, you can start to see other nodes working in the same way, such as the dot product that gives the cosine of the angle between two vectors. What it's really telling us is how similar are these two vectors, thinking of the vectors as directions. When they're equal, both pointing exactly the same way, it outputs 1. When they're perpendicular, or at right angles to each other, it outputs 0. And when they're anti-parallel, so pointing in completely opposite directions, it outputs negative 1. But in this case, it's remapping something different. It's remapping the similarity between two directions in space. And we can think of other math functions in the same way too, when we talked about radians and the way that we convert between degrees and radians, and the reason for even using them at all. Little setups like the pi over 180 or 180 over pi are ways of remapping one type of angular measurement into another. Try here with a regular gradient. My input goes from 0 to 360. My output goes from 0 to, in this case, an alpha value of 628.32%, or 6.28, which is 2 times pi. This gradient now converts an input in degrees and gives an output from its alpha here that is a scalar in radians. It's exactly the same thing. So remapping is completely and totally important to everyone, as it does so many different things. First, it just gives us a mechanical method for converting values where we need to be able to hook a certain type of data into a certain type of input. But it also lets us take stranger or more complicated numbers and work with those in a way that's more simple to us. And also, by understanding the concept of remapping, we can find a new way of thinking about some of the more technical or math type areas of the node editor, again giving us a new and different picture in our heads to follow in order to figure out the kind of effects and outputs that we want to achieve. So, a reasonably short and sweet little video we have there, but very important and well worth mentioning in its own right. So I hope that's given you a bit more insight into some of the tools available and the different creative ways to think about using them.